for sediment in beverages. See dregs. Sediment is a naturally occurring material that is broken down by processes of weathering and erosion, and is subsequently transported by the action of wind, water, or ice, or by the force of gravity acting on the particles. For example, sand and silt can be carried in suspension in river water and on reaching the sea be deposited by sedimentation, and if buried this may eventually become sandstone and siltstone. Sediments are most often transported by water, but also wind and glaciers. Beach sands and river channel deposits are examples of fluvial transport and deposition, though sediment also often settles out of slow-moving as standing water in lakes and oceans. Desert sand dunes and loess are examples of aeolian transport and deposition. Glacial moraine deposits and ice-transported sediments. Classification. Sediment can be classified based on its grain size or its composition. Grain size. Sediment size is measured on a log base 2 scale, called the Phi scale, which classifies particles by size from colloid to boulder. Composition. Composition of sediment can be measured in terms of parent rock lithology, mineral composition, chemical makeup. This leads to an ambiguity in which clay can be used as both a size range and a composition. Shores and shallow seas. Seas, oceans and lakes accumulate sediment over time. The sediment could consist of terrigenous material which originates on land, but may be deposited in either terrestrial, marine, or lacustrine environments, or of sediments originating in the body of water. Terrigenous material is often supplied by nearby rivers and streams or reworked marine sediment. In the mid-ocean, the exoskeletons of dead organisms are primarily responsible for sediment accumulation. Deposited sediments are the source of sedimentary rocks, which can contain fossils of the inhabitants of the body of water that were, upon death, covered by accumulating sediment. Lakebed sediments that have not solidified into rock can be used to determine past climatic conditions. Marine depositional environments. The major areas for deposition of sediments in the marine environment include littoral sands, the continental shelf, the shelf margin, the shelf slope, beds of estuaries with the resultant deposits called bay mud. One other depositional environment which is a mixture of fluvial and marine is the turbidite system, which is a major source of sediment to the deep sedimentary and abyssal basins as well as the deep oceanic trenches. Any depression in a marine environment where sediments accumulate over time is known as a sediment trap. The null point theory explains how sediment deposition undergoes a hydrodynamic sorting process within the marine environment leading to a seaward fining of sediment grain size. Environmental issues. Erosion and agricultural sediment delivery to rivers. One cause of high sediment loads from slash and burn and shifting cultivation of tropical forests. When the ground surface is stripped of vegetation and then seared of all living organisms, the upper soils are vulnerable to both wind and water erosion. In a number of regions of the Earth, entire sectors of a country have become erodible. For example, on the Madagascar High Central Plateau, which constitutes approximately 10% of that country's land area. Most of the land area is devegetated, and gullies have eroded into the underlying soil in furrows typically in excess of 50 meters deep and 1 kilometer wide. This siltation results in discoloration of rivers to a dark red-brown color and leads to fish kills. Erosion is also an issue in areas of modern farming, where the removal of native vegetation for the cultivation and harvesting of a single type of crop has left the soil unsupported. Many of these regions are near rivers and drainages. Loss of soil due to erosion removes useful farmland, adds to sediment loads, and can help transport anthropogenic fertilizers into the river system, which leads to eutrophication. Coastal development and sedimentation near coral reefs. Watershed development near coral reefs is a primary cause of sediment-related coral stress. The stripping of natural vegetation in the watershed for development exposes soil to increased wind and rainfall, and as a result, could cause exposed sediment to become more susceptible to erosion and delivery to the marine environment during rainfall events. Sediment can negatively affect corals in many ways, such as by physically smothering them, abrading the surfaces, causing corals to expend energy during sediment removal, and causing algal blooms that can ultimately lead to less space on the seafloor where juvenile corals can settle. When sediments are introduced into the coastal regions of the ocean, the proportion of land, marine and organic derived sediment that characterizes the seafloor near sources of sediment output is altered. In addition, because the source of sediment is often correlated with how coarse or fine sediment grain sizes that characterize an area are on average, grain size distribution of sediment will shift according to relative input of land, marine, and organically derived sediment. These alterations in marine sediment characterize the amount of sediment that is suspended in the water column at any given time and sediment-related coral stress.